Welcome back to Smith Coding and Design. I hope everyone is having a great week. I know the weather here in Maryland has been excellent. So with that being said, let's go ahead and jump into our stainless steel widget. Today we're going to cover Op 2. We're going to remove the hat of material off the backside. We're going to face it and then we're going to chamfer, and that should finish off the widget. So with that being said, let's go ahead and begin. All right, so for Op 2, let's go ahead and go down here to Op 2. You'll notice that our stock transitioned over to where it should be. So if we go ahead and just orbit, you can see our top hat of material there. And this is where that 50 thousandths that we went past the bottom of our part during Op 1 will come into play. So what I'm going to do is I'm going to go ahead and remove the top hat of material. So to do this, you are going to want to, measure with a set of calipers the center of your jaw and the center of your stock, and make sure that your part is indeed centered in your vise, because steel is not as forgiving as aluminum. So if you're off by 1/8 of an inch or 1/16 of an inch and you come through and you're overloading your end mill, it will disintegrate. Ask me how I know. So make sure that your stock is centered for this. So what I'm going to do is I'm going to go to 3D adaptive clearing, and we're going to use that 6 flute HEPM end mill again from Haas Tools. So we're going to select OK. And so this time what I'm going to do is I'm going to use a lighter cut, just in case we didn't put the part exactly on the center of the vice jaws. If there's any little deviation, I'm not going to disintegrate the end mill. So this time, again, we're going to be at 8,000 RPM. I'm going to go 144 inches per minute, which is right at 3 thou per tooth. And then what we're going to do is go here to passes, and I am going to go to my optimal load, and I'm going to make my optimal load not 10% the diameter of the tool, but 5%. So we're going to be moving faster but taking lighter cuts. So we're going to make up for not using 10% optimal load by moving faster and taking lighter cuts. What I'm also going to do is enable stock to leave, and that's going to leave 20 thousandths, again, feed optimization. So everything there looks okay. Our heights, let's see here. I don't know what that error is about. But anyway, let's look here. Model bottom. No, I want the bottom height to be highest of selected, and we want it to be the model top. We don't want to machine all the way to the bottom of our part. We just want to go to the top, and then just to make sure that we get all of the top hat and we don't leave a thin foil, I'm going to go ahead and just go 50 thousandths below the edge of that top hat of material. So that's it. So stock top for our top height. For our bottom height, we're going to go to the top of the model, and then we're just going to go about 50 thousandths below that. Okay, everything looks good there. Again, important, we are at 5% optimal load, and here we are at 8,000 RPM, 144 inches per minute. So we're going to select OK. And what it's going to do now is all we're going to do is blaze off the top hat of material. So we're going to do that in simulation, and I'll explain to you in a minute why we're doing this way. All right, so the reason we can do this is that our Z is the same for our G54, for G57, 58, 59, right? All of our Z is always referenced to the top of our rock lock base. So when we cut our jaws, everything is based off of that same Z. So we can safely come in here and remove the top hat of material and have our Z spot on. So let's go ahead and do that. So here we are removing the top hat of material, and you'll notice here that there is 20 thou left on top, but because when we did our 3D adaptive clearing in Op 1, we went 50 thousandths below the bottom of our part, you'll notice that there's no burr here on the edge, or there's no 20 thousandths of material hanging off here. That would interfere with our probing, interfere with our facing or any chamfering, anything like that. So this is a nice smooth edge along these faces that are the same length and width as our part. So that is known part geometry, which is exactly what we want, because what we're going to do now, let's go ahead and escape the simulation, is we're going to go ahead and do another probing routine. So I'm going to go to inspection, I'm going to go to probe, I'm going to select our silver CNC probe again. And now to make life easier, actually I don't even need to do that. All we need to do is go to geometry, and then again we're just going to select the edges of our part, so we can do that rectangular boss probing routine again. So there we go. And again, like we did with our probing routine in Op1, we got to be careful. We got to go over here and select actions, override WCS, but remember we're in position G59 now, so we want to use WCS 6, right? Because we are using a different vise for Op2. So that is going to let Fusion know we want to use G59 to drive our probe over and then probe our part. So that is what we're going to do. We're going to press OK, and then as always we're going to simulate. So here we go. Everything looks beautiful. Go ahead and exit our simulation. Go back to our home view. And now we're just going to go ahead and finish up Op2. This is going to go rather quickly. All right, so now what we're going to do is just go ahead and face. However, I did not like the sound of the shell mill on Op1. So what we're going to do is come back here to milling. We're going to do a 2D face again, but this time I'm going to use the 5 flute finishing end mill from Haas instead of the shell mill. So we're going to select that. Click OK. It's going to take much longer, but we're going to get a much better surface finish. We're going to adjust our SFM to the recommended SFM along with our feed rate, 1.2 thousandths or 1,002 tenths. Everything there looks fine. So we're at 260 SFM and right around 24 inches per minute. For geometry, we don't need to select anything. What we do need to do is come over here to passes. Because we're using an end mill, not a giant shell mill, we can get coolant to both sides. So we're going to go both ways. And then what I'm going to do is set my step over to half the diameter of the end mill. And so that should be everything. We're not using multiple depths, nothing like that. We'll go ahead and click OK. And then what we're going to do is go ahead and simulate. And again, all this is doing is just facing the top of our part. So nothing major to look at there. Just trying to get a beautiful surface finish. And that's it. So now what we're going to do is we're just going to go do a 2D chamfer. We are going to select the 1/4 inch Haas chamfer mill. Let's see if we can find that. There we go. We're going to select it. And then again, we're going to go to geometry. We're going to select the outside contour of our parts. For heights, we don't care. We can go to model top, selected contour as the bottom. For passes, again, I'm just going to default to a chamfer width of 13 thousandths. And our chamfer tip offset is right around 63 thousandths. Everything there looks fine. We're going to come in at 45 degrees. Go ahead and select OK. And that is it. We'll simulate. And that finishes off our stainless steel widget. All right, so that completes our stainless steel widget. I hope everyone has found the material insightful. Again, the overall goal was to provide some entry-level speeds and feeds for stainless steel, specifically 316 is what we're using here. Again, I'm also trying to use affordable tooling. That way everyone can follow along. I personally have the 5 horsepower version of the Silex 7, so if you're using a Tormach or a hobby grade machine with low horsepower, hopefully you can use my feeds and speeds, maybe with just some minor tweaks for your specific machine. If you like this type of content, let me know. I'm thinking about doing some more material specific widgets. I have some 1018 in the shop, and then I'm considering moving into titanium and then maybe into 4140, etc. So let me know what you think. Leave any feedback, any comments below, and I will catch everyone in the next video.